Welcome back everyone to George James & Associates Research Tools channel. My name is Stephen Lee, and today I'm going to walk you through hopefully a clear understanding of degrees of freedom in statistics and what that means. This is a concept that took me a long time to understand because it wasn't explained correctly, in my opinion. And just like the difference between the literature review and the theoretical framework, the link to which I will put in the description below. Please check out that video if you haven't. But based on that video and a couple of other videos of mine on this channel that have received the most views, I decided to make more videos like that. It basically explaining fundamental concepts of statistics and research. So without further delay, let's move right along to degrees of freedom. Now, just to back up a little bit, what do we do when we are engaging in statistics? You have to understand this before you can understand degrees of freedom. So remember, in statistics, you are simply looking at a population and you are taking a sample from that population, and that sample, most often, in order for it to be the best that it can possibly be, it needs to be random, right? It needs to be what we call a simple random sample. And so what we're doing is we are estimating. We are estimating and inferring, right? Statistics is not an exact science. If you were to ask somebody, what percentage of Americans wear blue hats or live in 1 or 2 bedroom apartments or enjoy eating bananas, you will never ever get an exact amount at any point in time. Why? There are too many people to poll instantaneously. Too many. So we need samples. So we take a sample, and that allows us to estimate, to approximate, to even average what percentage of the population. We can estimate what the real average is, the objective mean, as we call it, out there in the real world is based on our sample. That's the whole purpose of statistics, remember. And so when we get to degrees of freedom, you might think, and this is from the back of a textbook, of a statistics textbook, usually the front cover or the back cover has something like this. And so, again, we have this normal distribution curve. I'm going to explain a little bit more about that in a minute. But we're interested in a particular area under the curve, right? We're interested specifically in the distance between a particular observation, right, a particular instance, and the true mean, right, the true average as it exists out there, unknowable though. Remember, we cannot truly know what the real average is, what the true mean is. So we have to estimate it. We have to approximate it. And so this legend over here in the top left corner will show you that going across this way, we have our probabilities, right? It's the probability that the results appear by chance. And so that's your alpha, right? That's your alpha value. And so 0.1 is 10%, 0.05 is 5%, 2.5%, 1%, half a percent, and so on, right? 1/10 of 1%, and so forth. And then going down this way is our V, right? Or the Greek letter for V. And I'm blanking right now on what that is. And this is the number of degrees of freedom. Okay, so just based on this chart, we know that somehow degrees of freedom are important. Why are they important? Because your degrees of freedom ultimately are going to, it's derived from your sample size. It's derived from your sample size. And then the values here are the t distribution. I don't want to get into what all that is. The point is, you look at a table like this and it's not evidently clear as to what a degree of freedom is or what degrees of freedom are. Okay, so taking a step back again, this is a normal distribution curve, right? Most of you know what this is. Here we have in the middle the true mean. We have the true value of whatever it is that we're studying. And then we have the distance of a particular observation from that average, from that mean. And we know, right, that when you you take the random sample and you have all these observations, right, that are here under the curve, you know that any given observation, there will be a 68% probability that it lies between -1 and 1 standard deviation, or within 1 standard deviation of the mean. We also know that 2 standard deviations, right, on negative or positive, that an observation has a 95% chance of landing between the 2's and has a 99.7% chance of landing between the 3's, right? We know that. And so again, here's our mean, right? This vertical value here, this is the exact objective average or mean as it exists out in reality. This right here is our standard deviation. This is the distance of any one observation from that mean. And so again, we would explore this further if we were looking at one-tail versus two-tail tests, and I'll make a separate video about that probably. But suffice it to say, this is what we're looking at because we ultimately want to know, we want to approximate as close as we can to the real mean, right? We want to approximate. That's why in econometrics you have estimators, right? That's why you have BLEU, the best linear unbiased estimator, right? BLEU. And so that's what this means. So the question I have for you is, what does this curve look like? And this is where we're getting into me explaining what a degree of freedom is. This distribution curve looks very similar to a platter, a silver platter, right? It looks just like this thing right here that the waiter is holding. If you think of it, right, here's the top of the curve, and it sort of goes down, and you have the little tails here on the plate. It kind of looks like that. And so you may be thinking, what in the world does this have to do with degrees of freedom? So here's a room, right? We see this door off in the distance, this window off in the distance. And depending on what we're measuring, all of these dots are observations, right? In the social sciences, these dots are people that we are going to survey. And what a degree of freedom is normally it's n-1, n being your sample size, right? So we know that, we just don't know what a degree of freedom is. But most of the time, your degree of freedom is going to be your sample size minus 1. Why is it minus 1? Okay, so here's where I'm explaining to you what the degree of freedom is. So imagine that you're out in the universe and you are trying to measure any of those things that we talked about earlier. How many Americans wear blue sweatshirts? What percentage of human beings have blonde hair at any given point? We don't know. We don't know how much at any given point in time, but we can approximate it. In order to approximate, you have to have a frame of reference. You have to be holding on to something to anchor you inside this room of observations to be able to count all the observations. Otherwise, if you're not anchored to anything, imagine that this plate right here isn't there. We're trying to put down this curve, right, this normal distribution curve, but we have nothing to anchor it to. We don't have a plate. That plate is the degree of freedom. You need to have something to anchor yourself to in order to slat down that distribution curve. Otherwise, you have no idea where the mean is. You're trying to approximate the mean, but you don't have a reference point, and that's precisely what a degree of freedom does. Now, in other instances where you're taking two populations and you're comparing them, you're doing a match pair or you're doing something else like an ANOVA or a t-test between the two pairs, then in that case, sometimes you might have an n-2 degrees of freedom or something like that. But most of the time, if you're just doing a simple random sample and you're surveying the population and it's just normal statistics, normal econometrics, your degree of freedom is going to be n-1, n being your sample size. So if your sample size is 500, then your degree of freedom, right, is 499. And so it's your n, your total number sample minus 1. That's your degrees of freedom. And why is that? Because it's called a degree of freedom because that's the amount of freedom you have. But what you don't have is that 1, that n-1 calculation. That 1 is where you're not free. And the reason why you're not free for that one blip or that one observation is because that 1 is your reference point. That is the one thing you have to hold on to count everyone else in the room. So hopefully this explains to you what a degree of freedom is. I tried to bring in my silver platter example as the normal distribution curve, and the plate is the degree of freedom. You could also think of it as wrapping your arms around like a pillar or something like that. That is your degree of freedom. But if you don't have your one observation, you don't have your one degree of freedom, you're not going to be able to orient yourself to count for all the other observations that are in the room. And so if you have any questions, please post them down below. You can also directly email me. I'm happy to answer them and to help you out. So hopefully that you found this video valuable. Please like the video, subscribe, and turn on notifications for future videos. Thank you all so much. I tried to keep this video under 10 minutes and I almost made it. So hopefully this explains what a degree of freedom is. And if you have any suggestions for future videos, please drop me a line. Take care, everyone, and happy Thanksgiving.